We change from radical expressions to functions. So if you remember in the beginning of the year, the range is a set of all outputs or y values, and the domain is a set of all inputs. So if you have two functions, f of x equals negative 2x plus 6, and g of x equals 5x minus 7, this just means add the two expressions together. So you're going to add negative 2x plus 6, and then you're going to add it to 5x minus 7. So negative 2x plus 5x is 3x minus 1. Now to find the domain, think of all of the x values that you could possibly put in there. Are there any restrictions? So is there a denominator? Is there a square root that you can't have a negative number for it to be a real number? There's not. So the domain is all real numbers. Now I'm going to do f minus g. So I'm going to do negative 2x minus 6 minus, and I'm going to put this g of x in parentheses. And then at the end, I'm going to have negative 7x. It's going to turn into a plus 1, and the domain is all real numbers, because you can put any number in for x. You can also multiply. So I can multiply, so I can FOIL x squared plus 1 times x to the 4th minus 1. And then do the domain. So the domain for this one would be all real numbers again. You can put anything in for x, any real number. And then now I'm going to do f divided by g. So it's going to be x squared plus 1 over x to the 4th minus 1. And I can actually factor the bottom. The bottom is difference of squares, which factors out into x squared plus 1 and x squared minus 1. So these two cancel out, so you're left with 1 over x squared minus 1. I know I could factor x squared minus 1 further, but it's not going to simplify the numerator at all. So to find the domain for this, now you have a fraction. So that means that, remember, you can't divide by 0. So you can't put anything in for x that would make this denominator equal to 0. So the two numbers, so what you do is you set the denominator equal to 0. So x to the 4th equals 1. Take the 4th root. So x equals plus or minus 1. So the domain would be all real numbers except x can't equal plus or minus 1. If you want, you could also write in interval notation. So I'm going to look down here. This didn't turn out. This Google Doc didn't accept this notation, but if I look right here, a new thing is the composition of functions g with function f is written as g of f of x. This is called g of f and is defined as g of f of x. This is a notation that we use. The domain of g of f of x consists of the values a in the domain of f, for which f of a is in the domain of g. So when you're trying to figure out the domain, you have to first look at what is restricted or allowed in f, and then only plug those in for g. So here's how you do f of g of x with notation. So this actually looks like, this didn't show up, like this. Or you can also write it like this. It means the same thing. This is a little circle, right here a dot. So what this means is you need to evaluate f of 2 first. So you need to plug in 2 in for x. So 2 to the 3rd is 8. So I do f of 2 first. Now you take this 8 and you plug it in to g. So g of 8 equals 8 squared plus 7. 64 plus 7 is 71. So g of f of 2 equals 71. I should write 2. So this means do f of 2 first and then plug it into the g function. And then now this is f of g of negative 4. So that means you're going to plug in negative 4 in for g. So I do g of negative 4 first, equals negative 4 squared plus 7. 16 plus 7 is 23. So I'm going to do f of 23, which is 23 cubed, and then calculate that out. So composition of functions is important because it makes a difference on, here's a good example. In this, you go to Kohl's and it offers a 30% discount on all items, and then you use $20 worth in Kohl's Bucks. So $20 worth in Kohl's Bucks is a coupon, so it's a $20 deduction after you take the discount. So or is it, do you do the discount, or do you do the Kohl's Bucks first and then take 30% off? There's a difference. So use functions to model discounting an item by 30% and then applying the Kohl's Bucks coupon. So we're going to let f of x be a 30% discount. So that means that you're paying 70% of something. And we're going to let the coupon, Kohl's Bucks, equal taking $20 off of something. Okay, B, use a composition of your functions to model how much you would pay for an item if the clerk applies the 30% discount first and then the Kohl's Bucks. So you're doing the discount first, so the f of x needs to be on the inside. And then the g is on the outside. So you're going to take 0.7x and you're going to plug it in for this x. So this is equal to 0.7x minus 20. That's how much you're paying. C, use your composition of two functions to model how much you would pay for an item if the clerk applies the Kohl's Bucks first. So now this is going to be f of g of x. So g of x is x minus 20. So you plug that in for x into your f. So it's 0.7 times x minus 20. So when you do the distributive property, you get 0.7x minus 14. So how much more money is any item if the clerk applies the discount second? So you're actually going to pay $6 more. So it makes a difference, and you can show algebraically. See how it's $6 more because you have subtracting 20 and subtracting 14, and the difference between the two numbers is 6. So down here, find the domain of each. So just more practice. So f of x plus g of x is 2x squared plus 3x minus 1, and the domain is going to be all real numbers. This is going to be 2x squared minus 3x plus 1, and you have another all real numbers. This one you're going to multiply the 2. So that's still all real numbers. We don't have any fractions or square roots yet. And then f2x squared over 3x minus 1. Okay, now you have a denominator. So you set your denominator equal to 0. So x can be all real numbers except for 1/3. And then this notation down here means take g of x and plug it into the x and f of x. So it's 2 times 3x minus 1 squared. The domain would be all real numbers, because you could put any number in for x, in G and in F.